Okay, we're doing the combined gas law. Now we're gonna pour this water with food coloring onto the plate, and we're gonna put the cup over the candle, and the candle should suck up all the pressure in here, with thus increasing the volume. So the liquid will go from outside the cup inside the cup. Now pour in the liquid. Like so. Now you notice that the fire is starting to dim out, and as it dims out, it is also sucking in a boatload of water.
As you see.
Now notice how the flame died out, and as the flame began to die out, all the water started to get sucked into the cup. Now hold down the... Okay, we're doing Charles' law. It's where with a constant pressure and temperature in degree Kelvin, the volume and the temperature should increase and decrease equally. Now we're going to put this in the freezer at negative 18 degrees Celsius or 255 degrees Kelvin, and with a length of 9 inches, it should decrease to a smaller length. Okay, this is the Charles law with the balloon in the freezer. And when we put the balloon in the freezer, starting off at 9 inches with negative 18 degrees Celsius, after 30 minutes of just being in the freezer, it decreased half an inch to 8.5 inches, which proves that with a lower temperature is also lower pressure. Okay, this is Avogadro's law, and as you blow moles of air into some sort of container-like thing, the volume begins to increase along with the amount of moles. And now, as Landon deflates it, as the volume decreases, so does the amount of moles inside of the volume. This is Boyle's law, and here we have whatever this thing's called, and a marshmallow inside it. And the theory is that when the pressure increases, volume decreases, and vice versa. So I'm going to put my finger at the end of this tube. I'm going to push down, thus decreasing the volume, increasing the pressure, and the marshmallow should shrink. Ready? Now, as you can see, the marshmallow has shriveled up like a little raisin. Now, starting from the bottom, putting my finger on here, if I increase the volume and decrease the pressure, the marshmallow should expand, which it in fact does. Okay, here we have Gauss-Lussac's law, and so with the constant volume, the temperature and the pressure are equivalent. So with the hot temperature and high pressure, when we put it into the cold bowl, the temperature will decrease so fast that when the pressure tries to match it, the can will implode. And that's Gauss-Lussac's law.